Our group is talk about the Asian calculating devices. Take regularizing calculating tools as an example. We will talk about 4 parts. Introduction. The history of mathematics is an important part of mathematical culture. In mathematics teaching, the history of mathematics as a career to penetrate the mathematical culture, the development of mathematics anecdotes, mathematical concepts generated by the background information shown to students, help to deepen students' understanding of the real process of mathematical creation, experiences, mathematical ideas. Below, take the lesson of recognizing calculating tools in the first book of the 4th grade of the PEP edition as an example to talk about how to understand the process of mathematical creation through the history of mathematics. The lesson duration is 40 minutes. Is part of the unit recognizing large numbers, which focuses on enabling students to understand and recognize computing tools, including the abacus and the calculator, and to be able to use these tools to perform basic calculations. This unit includes 5 sections: recognizing numbers up to the 100 million, the creation of numbers, decimal counting, recognizing number over 100 million, and recognizing calculating tools. By recognizing calculation tools, one can have a deeper understanding of numbers, learn how the Asian countings. It is also helpful for subsequent learning. A student will be exposed to larger quantities of calculations. Learning about large numbers and learning to use calculation tools can improve student problem-solving skills. 4th grader has a foundation in math. They are able to perform simple addition, subtraction, multiplication, and division, but they are not yet proficient in recognizing and using computational tools. Before learning this lesson, students may have only come across calculators and know less about abacus. Therefore, teachers need to make students understand how to use the abacus and the calculator and be able to use them flexibly for calculations through vivid explanation and practical exercise. The first, students can understand and the development of computing tools from ancient counting chips and abacus to modern computers and master their basic principles and methods of use. The second, by creating mathematical history situations, such as introducing the background of the use of the abacus, the invention and the development of the abacus, students are guided to explore the process of the revolution of computational tools and to cultivate their inquiry ability and logical thinking. The third, let students feel the important role of the calculation tools in the development of mathematics, appreciate the charm of mathematical culture, and stimulate their interest in learning mathematics.
Let's talk about the key points and difficulties in teaching. The key point is enable students to understand and recognize abacus and counting rods and learn to use them for basic calculations. And the difficulty is the usage methods of the abacus as well as how to select appropriate calculation tools based on actual situations. The teaching model, HPM. For many years, most students have shown resistance to the subject of mathematics, considering it highly abstract. This is extremely unfavorable for the development of students' thinking and mathematical abilities. Therefore, teaching the history of mathematics is a good way to stimulate interest. Chinese scholar earlier stated that the story of mathematics has moral education value. Integrating ancient Chinese mathematical achievements into mathematics education and introducing representative mathematicians and mathematical works to students can enhance their understanding and respect for the wisdom and creativity of their ancestors, and at the same time stimulate their national pride and patriotic enthusiasm. In the latest Compulsory Education Curriculum Standards 2022 edition, the history of mathematics is mentioned in the curriculum contents, curriculum implementation, and textbook compilation suggestions. During the textbooks of PEP edition, the quantity of the history of mathematics gradually increases from lower grades to higher grades. From the time students enter primary school, they are required to perceive and understand the history of mathematics. Then, as students grow older, the integration of the history of mathematics into the teaching gradually increases during the process of their cognitive and thinking developments. Here are the relevant contents in grade 4 textbooks as example. The history of mathematics presented in the textbooks includes both ancient and modern, as well as domestic and foreign aspects, covering a wide range. Currently, teachers' attitudes towards integrating the history of mathematics into teaching are positive. However, there are problems in integrating it into the classroom, mainly the following 4 aspects. The teaching objectives of integrating the history are deviated. The exploration of the teaching contents of the history is not deep enough. The teaching methods are monotonous, and teachers' understanding of the history of mathematics needs to be improved. By exploring the reasons, it is found that teachers have heavy teaching tasks and high exam pressure on a daily basis. There are insufficient teaching cases of the history of mathematics for teachers to refer to. The constraints of traditional teaching models and teachers' own weak mathematical history literacy. In our course, Recognizing Calculating Tools, the HPM teaching model is applied. Through this course, students not only master the usage methods of calculating tools, but also gain a deep understanding of their historical background and development process. Thus, they can better comprehend the information process of the mathematical knowledge and cultivate core mathematical literacy. In this class, we have delved into the study of relevant historical knowledge. Moreover, we have attempted to present the teaching contents in various ways, such as using multimedia tools like GeoGebra to explore various approaches to teaching the history of mathematics.
Here is our teaching design. We start 5 minutes with an engaging introduction to get students involved through hands-on activities. Next, we discuss why ancient people create tools to help with calculation. Understanding this reason behind this invention helps students connect with the practical needs of our ancestors. In part 3, we focus on 2 specific examples to explain how calculations were done in the past. Finally, we bring the discussion back to the present by reviewing modern calculation tools and do the summary. In this section, we cover recognition of large numbers and focus on lesson 2, the creation of numbers. First, we encourage students to use everyday objects for calculation, and then ask questions like, do you know how ancient people do the calculations? Students are expected to answer with something like fingers, pencils. We connect their responses to the concept by explaining why Asian people used fingers and cardinals for counting. For example, people realized that fingers were not enough, so they added cardinals to count further. This part can organize the students' responses in a timeline system. We also explain the difference between countings and recorded numbers, because they sound the same in the Chinese, but they have different meanings. Next, we introduce tally marks, notes on strings, and symbols to show the Asian people moved from simple counting to more complex method. We start with tally marks, then we move to notes on string, explaining how different regions have different systems. Finally, we show how counting method evolved from concept to abstract.
The counting board is a very ancient calculating tool, first appearing thousands of years ago in Egypt. Later, the ancient Greeks, Romans, and medieval Europeans also used it for calculations. Although we now have calculators, the counting board can still be used to learn mathematics. The usage is that numbers were represented by moving pebbles within the groups. During calculations, the position of the pebbles will change according to addition or subtraction. For example, to represent the number 123, one pebble will be placed in the hundreds group, two pebbles in the tens group, and three pebbles in the units group. The design purpose is that the design intention of the counting board is to allow students to learn about the mathematical culture of Asian Western civilization through its historical context, broadening their international perspective. As an introductory part of the course, the counting board lays on the foundation for learning more complex tools, such as counting rocks and the abacus in the future, enabling students to experience the fun of mathematics through hands-on activities. Counting rocks are an ancient Chinese calculating tool primarily used for mathematical operations. They are usually made of small bamboo or wooden sticks with standardized legs and shapes. Counting rocks represent numbers through different arrangements, such as vertical or horizontal placements. This tool was widely used in ancient times to help people solve various mathematical problems. And the design purpose is that by arranging the small bamboo or wooden strips in vertical and horizontal patterns, students can understand the combination and the composition of numerical digits. At the same time, the use of counting rocks helps students grasp more complex calculation rules. And this is a simple practice for students to distinguish what the counting rock stands for. And the design purpose is that help them familiar with how to express a number in Asian solution by counting rocks, may a presuppose for students learn further in history and usage of the Asian calculators such as abacus.
In a certain period of time, counting rules can meet people's computing needs, but with the process of society and higher requirements for computing efficiency, its limitations are gradually exposed. As a result, people innovated and improved the calculation tools and invented the abacus. After that, the abacus was gradually improved to replace the counting rules. The abacus improves the shortcomings of counting rules, which shows that mathematics
mathematics is constantly updated in the development of history. Students can deepen their understanding of ancient calculating devices through the history of the abacus. Explain the origin and survival of the abacus. History explanation can make students feel the wisdom of ancestors, realize that the abacus is a calculation tool and a cultural symbol, representing national wisdom, and improve students' interest in the history of mathematics. Students are encouraged to think like historical figures, understand the logic of the invention of the abacus, and develop the ability to analyze the problems from a historical perspective. Shows the names of the parts of the abacus and introduce how to use the abacus. In this process, students gradually understand the basic structure of the abacus, gradually understand the principles and steps of the abacus operation, and can identify how numbers are represented on the abacus. Finally, improve students' logical thinking and problem-solving abilities. Exercises help students familiarize themselves with abacus structure and reading methods to improve accuracy. Students can quickly and accurately read the numbers from the abacus, understand the corresponding relationship between the position of the bit and the value, and enhance the understanding of the numbers. In the early 17th century, the slide rule was invented. In the middle of the 17th century, a arithmetic machine was invented. In the 1940s, the world's first electronic computers were invented. Nowadays, we use calculators. The course ends with an open assignment. Through open assignments, we can stimulate students' interest in learning the history of mathematics, enhance their understanding of the history of the abacus, and improve their independent learning ability.
This is the summary and reflection. Firstly, we divided the introduction into 4 parts to introduce ancient calculating devices to the student and arouse their interest in exploring them. We conducted a student-based activity in which students use objects around them as tools to perform simple calculations, introduce students to ancient methods of calculation, the difference between counting and notation, and ways of calculating complex numbers. Formal part of the course, the students were introduced to the history, use, advantages and disadvantages of the abacus and the abacus plate, following a timeline from ancient time to the present, the historical background of the abacus, the name of its parts and how to use them, and with the GeoGebra software, we demonstrated the students how to use it and arrange some exercise to help them understand it better. In terms of modeling computer tools, we selected calculating rules, electronic computer, electronic calculator. At the end of the section, we arranged students to collect abacus-related historical stories. Use it to stimulate students further interested in learning. Our teaching is based on the historical of mathematics pedagogy, but there are some areas for improvement. For example, the pedagogical tools in our classroom are rather homogeneous. Although GeoGebra is used in the section on the use of abacus, most of the time is shown in pictures and narrowed by the teacher. We could try to make the learning methods more diverse and better involve the students in the classroom by preparing teaching tools such as abacus and abacus trips and letting the students work on them directly. Although we have allocated time for each section, there may be some uncertainties. For example, during the student practice and discussing parts, the teacher spent too much time demonstrating the use of abacus to the students using the GeoGebra, which lead to insufficient classroom time, and we need to consider reserving more time for this.